right, so welcome. I have updated the Canvas pages, so they've gotten started to be updated. So now when you click on the calendar that's on the left of your menus, you should see something that looks like this. So a little hard to read, but every Monday there'll be a kind of a reminder to look at the module for that week. And so since I'm only starting it right now, this one for this week is for the course introduction, so please go do that. There's going to be a quiz that will be this Thursday for that one too, so there'll be one extra assignment this week for that. So do the course orientation and then the week 1 and week 2. So week 1 just has the content from last week. There's no assignments on it, but it will have the learning material that we did last week. And then coming up on this Thursday, you can see there's an assignment, course orientation, and week 2 homework. There'll be a quiz that I'll update later. So on Friday, there will be a quiz on here also. So do note that there will be a quiz this Friday. This does not contain your lab work, so that will be in the separate course 22 or 1245 and 1050. I haven't updated those yet, but I'll work on getting that updated too for the due dates that are on there. So if you have these calendars on there, this is one way to look at when are things due. Okay. The other location you can look for information. So wrong class. Okay. So under the course itself, the front page has not been updated yet. It still just has the modules, but it will be changed to have the weeks on there. So the links will be there on the front page. And then also under the modules themselves, you can click on the modules. The first one are these lectures for the semester. So this is where you're going to go to find the lecture material that I have been sending you through the announcements. So I will no longer be sending those. They will be posted here. And so you'll have the lecture information as far as the topic. The next column is the not annotated notes. The next one is the annotation, and then the video. If you miss class, then you can go back and look at that. And if you want to just go over and review it again, you're welcome to go back and look at the videos. So feel free to utilize that material that will be there. And then going forward, as you see, I did upload these this morning, so you have the lecture 4 notes here also if you want to get those and download them before we start. So questions on where to find the lecture material? Everybody clear on where to find it now? Okay. All right. Then also underneath the modules, you will see the different sections. So the course introduction, start here. So start working your way through this material. So start at the course introduction, go through the start here. It has a little more information about me, the links to the syllabus, and then some of the other relevant information. And then the course orientation quiz goes through things I want to make sure that I've repeated 3 times to you. So hopefully make sure you do read that and get information. There is one link in the course orientation that it says on how to succeed. That one has not been updated, but it will also be in this course orientation or course introduction section. So it will have a little page that's about how to succeed in this course. So do review that one also by Thursday. And then under each week will be it will look kind of like this. It will have the learning material. It will have some of the handouts that might be good for you to have. This one has like a summary of a 1-pager for like some of the equations that I've said to memorize, some of the procedural steps. And then beyond that, there'll sometimes be like there's a cookbook on the Node series parallel. You may or may not find this helpful, so just note that there's other resources. Make sure you look at them, see if it helps you or not. If not, ignore it. If it does, great. If you're also finding like I still am not understanding something after you've utilized this material, reach out to me. I'm happy to provide an additional video or some additional information to also provide you more information on a specific topic. Under each topic, then you're going to see that there's going to be some practice problems. So these are specific, like go practice these. They're going to be very useful. There'll be the links to the solutions, and then in the back of the chapter problems, the ones that I've highlighted here have the answers in the back of your book. So if you wanted to attempt these, then you can go look, and in the back there'll be the value itself. So they're another way to practice and get those. All right, and then there'll be like a video. So typically each of them will have some reading material, some self-assessment way of self-assessing. Are you doing this? If there isn't a link to a self-assessment, use the ULB link to the chapter itself that came from, and try those problems that are in the chapter. And then there'll be a video support option. And so you'll see that for each of these topics. Some of them may have more videos than others. I've tried to narrow it down to have at least one. Oh, that's interesting. So KVL. Okay, I need to update that one, that link. It looks like it didn't copy correctly. Oh, interesting. Okay. So Ohm's law is not the one that's working. Okay. All right. I will get that corrected today, but all the material will be there. And then under this week's module, you're going to find series and parallel, which we're going to talk about more, the equivalent resistance. And then on Wednesday, we're going to move into the voltage divider and the current divider. And then each week, you'll have that assignment on Thursday. And so on this, underneath that second, or underneath each week, you'll see the week homework. So week 2 homework will be due this Thursday. And then you're going to see the assignment that's also due this Thursday. And then I will include there'll also be a link once I create it for the quiz that will open up. It opens up like Friday at midnight. So if you're an early riser and want to get it done early in the morning, you can. Or if you're late and you stay up till then and want to just continue on with the quiz right after you finish the homework at 11:59 p.m., you're welcome to do that too. And then it will stay open on Fridays until the end of the day on Friday at 11:59 p.m. So you'll have any time that day to attempt the quiz. So this week quiz will be based off the homework, so KCL, KVL, Ohm's law, power, and equivalent resistance. So the titles of whatever's in the homework will also be the quiz topics. So they'll be the same. I've had students that always ask me, well, they'll want to go retake the homework. So note that the homework is pulling questions from a database. So if you get something wrong on the homework, note that the next time you open it, you're going to get new problems. So just be noting that. Some students like that, some don't. So hit and miss if you're going to like it or not. Just find how it works for you. Some students will keep it open till they've checked with a TA to make sure all their answers are correct before they submit it. Others are like, I want that extra practice, so they'll keep going through and get new practice problems. I request that you don't keep using that for practice after you submit your last one, and instead move to the Unit 1 practice problems, which also draw from the same database. So those will be extra practice, but these are going to get counted as extra credit instead. So this Unit 1 practice problems extra credit, I will have another link on the modules, so those will be obvious where they are in the future. And there'll be one for each unit. So typically you'll want to go there to do the practices. And again, it draws from the same database as the homeworks do, but then it's easier to record and not get confusing. Okay, any questions? Okay, you guys clear on how to find information now? Okay, so now going forward, the due dates are valid, so do make sure you do the assignments that are coming up on this Thursday. Okay? All right, any questions about any material up to now? Yes?
I'm a little confused about like the assignments on Canvas. Is it like divided by module and lecture or like week?
It will be divided by week.
Okay.
So ignore the modules for now.
All right.
I will update them to just be week only, but I'm still...
And are the individual homeworks like 1, 2, 1, 3, 4?
Ignore those two.
Those aren't valid anymore?
Correct. I took off all the due dates of them, so hopefully they don't even show up on your calendars now. You can use those for extra practice. So if you do want to go in there, and they typically will have some similar problems, so you can go through those for extra practice. So I've left them on there for extra practice. I'm going to try and organize them to link them into the weeks instead, so it's not so confusing of what those are.
Okay.
Is that more clear? So yes,
Yeah.
look at the week only. Yes.
Will there be a change in the materials required for the labs as the Canvas page are being updated, or can we trust what it says on the syllabus right now?
Yes, what's on the lab portion is correct.
Okay.
Well, I should say I haven't gone over it very carefully, so there most likely will be correct. If it says that you're required to get an analog discovery 2, you don't have to get those. It's an optional. So they do offer to sell those in the stock room. They're going really fast, so if you want to get one, you might want to get that. What it is it's a portable lab bench equipment that you can take home and work at home on any lab work. It lets you generate signals, an oscilloscope is in there, a multimeter, and so it's nice and it will provide the power too. So if you ever want to work at home, I would suggest getting that from the stock room. I think they're right now at $300. The new ones are $480 for our discounted price. So I know they're selling out of those really quick. So if you do want to get your own to have in the future, I would suggest maybe trying to grab them pretty quick. Otherwise, you'll use the lab bench equipment in the labs themselves, and so that's why that one may not have been updated to be optional. Okay. Otherwise, the lab kits are purchasable in the stock room, and if you don't know where that is, go to your lab section and ask the TA to show you where the stock room is. All right, any other questions? Yes.
Could you also tell us about the discussion / lecture, like, which is at 4:30?
Oh, yes, thank you for bringing that up. Okay, yes, so the discussion sections are optional. They will be counted for extra credit. So if you want to go and get extra credit for attending those, you're welcome to go get some extra credit points. So they will take attendance in those, but it won't count against you if you don't go because they're extra credit instead. So it will be led by one of our lead TAs, and she's great. She's been doing it for several semesters. I think she moved on into her grad career. So she was an undergrad student here and has gone into her grad career now. So she's a grad student. So she knows where you're coming from, very understandable about the way we teach also. So she tries to use the same terminology that we've been using. So she'll go over problems that are similar to the topics we're discussing. So they're going to be, and it will be starting today, yes. So she said she was going to try and send an announcement to make sure that students do know that she will be there today. So they'll be every Monday and Wednesday now going forward. All right, clear? And it looked like you still had an additional question, gentleman with the, yeah. Did you have more question? Yeah.
Yeah, so I mean, will that, the kit, the lab work we can do at home, will that be usable in future classes? Like, would that apply?
Yeah, so you'll be able to use it for any lab work. So it's a portable whole lab bench equipment. So some of our students have used it for all the way up to their senior project and use it at home. Most of the time you still have to come and check it off with the TA, so you'll bring that with you and check it off in the lab with the TA.
Thank you.
Uh-huh, yes.
So do we need to be like bringing it every week to the lab, or do you have the supplies already in the lab?
So the portable lab bench equipment, if you use it, you're welcome to bring it and use it, or you can just use the lab bench equipment.
Okay.
So one or the other, whichever you prefer. If you do buy it and you're like, oh, I want to continue to use this to be very familiar with it, you're welcome to.
It was like the one that was like $40 with all the different things combined.
So that one is the multimeter and ammeter. So that one is different than the $300 one. The $300 one will have your battery and your oscilloscope and your function generator as part of it too. It does do measurements too, like the $40 one.
That as well?
So it's optional if you would like to purchase that one. So it's not required. I do recommend if you do get that one to make sure you're familiar with the lab bench equipment, which industry will expect you to be able to use at one point. But typically our students end up being comfortable with both if they get both, or if they get the portable one too. All right, any other questions? Okay, you guys ready to move on to material? Okay. So last time we went over the ordinary node, extraordinary node, branch loop. Well, all those became more implied as we moved to KCL and KVL. But please, if you're still struggling even sometimes with like, why did you do that? What did you do? Stop me and I'll try to explain. KCL, KVL, Ohm's law, and power. And then today we're going to move into reviewing a lot of those and then also moving into calculating equivalent resistances, which we didn't get time to go to last time. So those are the main topics that we're going to go through today. Okay, so here is a circuit, and now you want to solve it. So solving for this variable, ix, which is drawn in this direction. Again, if you're sitting with somebody next to you that you don't know, please introduce yourself. Feel free to work with your neighbors. And try to solve for ix.
I started out one on Thursday, well, I think so. You're supposed to write about the cheese, and then the reflective one that's like, oh, whatever you do in class. We didn't do anything in class, so I just assumed, like, okay, well, I'm just gonna reflect on the one that. I think it's reflective. I did it like. I didn't count for it, but I don't know what I did. Yeah. Okay. It was like 2.5 pages, but it was double spaced. I figured I just let it keep on. Yeah, mine is. Yeah, double spaced, because I figured that, she's gonna actually read like 25, 30 pages. Get high fatigue. Because I didn't have to write an essay my first week, and I don't have to write an essay this week. So you already did it.
Yeah, once we got into it, it felt like an essay. Whereas either working on an essay or preparing to work on it.
Yeah.
Sum of all the current.
I haven't started this, sorry.
I mean, that's what everybody else is doing.
All right, so let's go through this solution. So it looked like everybody came to a consensus that did submit an answer here. So let's see if that was correct. So first thing to recognize is, like, what am I trying to solve for? So when I look at a problem, I always try to look at what am I trying to find? So in this case, I know the variable is ix that I want to try and find. So I'm going to try and write an equation that contains that variable in it. And then I'll look at whatever's not known from there, see if I can write another equation that contains those variables until I can get to enough equations for the amount of unknowns I have. So in this case, if I have 2 unknowns, I need at least 2 equations, and maybe I need more if I can keep bringing up more unknowns. So right now, I'm like, I need at least 2 equations. So I want to write an equation with ix. What tools do we know? Kirchhoff's what? Okay, so Ohm's law. So we know Ohm's law. So we have 3 techniques that we kind of know right now. We have an Ohm's law, KCL, and KVL. So those are the 3 ways of writing equations that we know right now. So we can attempt all of them. So Ohm's law is going to be helpful if I know the voltage across a resistor, or I'm trying to solve for the voltage and I know the current. So in this case, I don't know the voltage across that, so Ohm's law is probably not going to be as helpful. I could try KCL and KVL. So for KCL, I need what kind of a node in order to write KCL?
How do you not know the voltage is not 12? For Ohm's law.
So if I am going to highlight all of these, so highlighting all the nodes, again, you color the wire until you hit an element. So I noticed last time, some of you may still want to circle all your elements first. So identify the elements and then highlight in between each of the elements until I hit an element. So I got red already, green. So down here, oops, there we go. And then I hit an element, and then I hit an element. So 12 volts is just going to be between this wire and that wire. In order for it to be across the 2 ohm, I have to have red on it and then green on the other side of it. So if something is in parallel to it, then you can say it's that value of voltage.
It's the resistors that.
But that resistor in the 5 ohms, then you know for every resistance there's going to be some kind of a voltage drop across it. So because there's a drop there, you know the top of that 2 ohm is not going to be 12 volts. Does that make sense? Mm-hmm. Okay. Other questions? Great question, thanks. All right, so from here, I've highlighted the nodes, and so I know what is this blue one, ordinary or extraordinary? Ordinary. Okay, good. Ordinary. The red one? extra, and the green one? Extra, correct. So for the extraordinary nodes, I can write a current summation. So with these, they have to be only, well, I shouldn't say only. I'll back up. So in an ordinary node, what does that mean? So the other thing you have to identify are loops and branches. So first is going to be a branch. So the thing to remember about a branch, how many currents can you have in a branch? They're looking at me because I talked to them about this. One current grid. Okay, remember the one current. So we can only have one current in a branch. We can have multiple voltages, but only one current. So that means if we have one current, the current is already labeled I here. So I'm trying to think how to highlight this. I'm going to draw it like this. So that is going to be one branch. So a branch is in between two extraordinary nodes. Between two extraordinary nodes. So this would be a branch, which means all the current has to be the same here. So I could draw this current either to the right of 5 ohms, I could draw it going through the 5 ohms, I could draw it before, I could draw it going through the voltage source, I could draw it through there. All of those are the same current, and we would label them the same, which is I in this case. So the only thing you have to remember is that it has to go in the same direction of whatever was already labeled there. So that's why we know it goes from the bottom up around, because of the way it was labeled up at the top. Okay. All right, so knowing that, we know that I is there. What about blue? This would then be another branch, right? Because between two extraordinary nodes. And then this is going to be a branch. It only has one element in each of those different branches. So because they're different branches, they're going to have different currents. So the 1 amp is going to go around to this, through this wire to the actual node. And the 1x can go down, or it can be drawn below, or not 1x, IX. So this is going to continue to be 1 amp as that goes around, and then IX will be different than that. So again, one current in a branch. I'm just going to delete some of these so it's not quite so messy. Maybe.
And currents are measured in amps.
Currents are going to be measured in amps, correct. What is voltage measured in?
Joules per coulomb.
Which is also
Volts.
volts. Thank you. Yes. Okay, so I'm erasing these, but again, make sure you're drawing on each of these till you're comfortable with it. Okay, so now we can do KCL, and we have two options with the KCL. We can do it at the top node or the bottom node. So I just am picking one, so I'm going to pick the top one. So again, even though I'm putting a dot there, everywhere on that red is the same exact voltage. So coming into the node, I have I. Coming into the node, I have 1 amp. And going out of the node is IX. So I have I plus 1 amp equals IX. Two unknowns here, right? And it contains my one that I am trying to find, which is IX, my unknown. So now I need another equation that contains I in it. So if I can try a current summation again. And so trying a current summation on the bottom, I have I going out and 1 amp going out and IX coming in. Same equation, right? So that's not going to help me. So I'm done with as many options as I can do for the KCL. So I need to move to KVL. So KVL we have to identify. So with KCL, identify nodes and particular extraordinary nodes. And with KVL, you need to identify a loop. So as you saw last time, I like to just start in a corner. So I'm going to start in this left-hand corner. And I'm going to take a loop pathway around here in this direction. As I go here, I have a plus, but there's nothing labeled for the 5 ohm. So how do I tell what polarity the 5 ohm has? The direction of current, correct. So the direction of current has the left on a positive on the left, and on the right is a plus, or a plus is the positive on the left, and a negative is on the right. And then again, the current can be right above it, and again, it's going to be the same direction of polarity, so plus to minus. So this would be a minus. And then same thing here, plus to minus. I can draw it right there also, and it would be a minus. So as I go around that loop, I started in the left, I go through the 12, I go through the 5, I go through the 2, and it's a plus, minus, minus. So plus 12, and then it would be a minus of the voltage there, and I can label that as a voltage if I want, or I can do in my head Ohm's law right away. So Ohm's law would be what for the voltage?
5 times I.
Correct. So it would be a minus from the polarity, and then 5 times I. And then minus IX times 2, or 2IX. Equals 0. And that would be my loop. A side note is that there is a voltage across the current source that is unknown. So you cannot assume that the voltage is 0 there. So we have a voltage across this of Vx. So if we try and take a loop with that one in it, we add an unknown variable in there. So typically when you take voltage loops, you'll avoid taking the voltage loop with the current source in it if you can. So with this, therefore, try to avoid a KVL with a current source in it. Okay, so now I have 2 equations and 2 unknowns. For those of you who may be farther along in math, I think it's math 2250. If you get a set of equations like this, you'll learn actually how to manipulate them into a matrix form and then solve it with a matrix. So you can do that if you are that far along in math. A lot of you may not be there yet, so you can just algebraically solve these. So this is easy enough with 2 equations, 2 unknowns, just solve one for one variable and then plug it into the other. But note that as you get more advanced, you can do a whole set of equations, 10 variables, plug it into a matrix, and actually solve it that way. So here I can solve one for the other. So if I am trying to solve for Ix, so I'm going to just manipulate this to be I is equal to Ix minus 1. I'm going to drop my unit while I do my algebra, and then I'll add my unit in at the end. So I do want to check, that is one way of checking to make sure your equation is correct, is that your units for each quantity is the same. So I is going to be in amps, 1 amp, and Ix will be in amps, so great. Down here we have volts. So 12 volts. I times R, so 5 was 5 ohms. So this is going to be an ohms times amps, which is equal to volts. And 2 ohms again. And then IX will be amps. So again, we have volts. So we are good here. So that's another thing to kind of check is, do my units make sense for each quantity that I'm adding or subtracting together? They do need to be the same unit to be able to add or subtract. So here I'm going to plug in the I from up here. So I have a plus 12 minus 5, and then IX minus 1 minus 2IX equals 0. So this gives me minus 7IX. Plus 5 plus 12 equals 0. So 17, and then take the minus 7IX to the other side, becomes a positive 7IX, and then divide by 7. And that is the value of, what was it, 3.4. 2.4. The 2.4, 3.4 people found.
People found 3.4.
Yeah, 3.4. Did I add these right? 7, 12, 5, minus 17. Plus 5, so it'd be 17 over 7. 7, yeah. So it should be 2.4. So same error, so yes.
There is that 1 amp on the other side. Do we count for that? Since we're going off that top node, it has to equal, like everything coming in has to equal the current coming out, right? So that's where that extra 1 comes from? No?
So let's see, 2.4. So 2.4 volts, so we would have 1 and then 1.4 volts. So now we know IX, we can find the voltage at the top node if we ground the other side. So if we ground this is going to be IX times 2, which will be 2.4 times 2 for 4.8. 12 minus 4.8 divided by 5. Whoops. Minus 4.8. And so I here will be So I'm going to leave it as an exercise for you guys to solve to find that I was 1.4. And there's 2 different ways you can solve for that. Okay, any questions? Yes. Yeah, go ahead.
Why can't you use Ohm's law and then add 1 amp to your answer?
What would you use for the Ohm's law?
If you use 12 volts,
So remember, 12 is only between here and here, not across any resistance. So you can only use it if it's in parallel directly with the resistance. And so we can't combine, the 2 ohm is not in parallel with the 5 ohm, nor is it in series. So the 2 ohm is in parallel with the 1 amp.
But is the voltage source in series with the 5 ohm?
So it's in series with the 5 ohm.
So could we find the current across the 5 ohm resistor and then add 1 amp to it? Or I think that's what most people did.
Yeah.
Maybe that was wrong.
So on this 5 ohms, you know that this is 12 volts but you don't know what this one is until you find the current and solve it to actually find that it's 4.8 volts. So you could do, so then you could find the I, which will be 12 minus 4.8 over 5. But you can only do the Ohm's law if that's 0 on the right. Then you could do 12 over 5. But remember, it's the voltage difference between the two nodes. Does that answer your questions?
Yeah.
Okay. Other questions? So is that what everybody did, was the 12 over 5, and then you added 1 amp to it? Okay. So if you did that, which I think everybody here know that you're all together in this, do you see now why that's not correct? Okay. All right, great. I'm going to just post the solution for this one to have you guys have an extra practice problem. So we're going to move into the total resistance. So total resistances, if you identify that you're in series, all you need to do is add all of your resistances together. Nice and easy. 4 elements that are in series are connected by ordinary nodes. Resistors in parallel are going to be connected by extraordinary nodes with same connections. And this is where it's very easy to see if you color them. So going back to the coloring, make sure you color them, and then it's easier to see that they are the same because they're the same colors on the extraordinary nodes between them. In this case, this would be your equation. So if I have R1, R2, R3, when I highlight these extraordinary nodes, I see that they do indeed have the same colors, in this case left and right, on them. Then they're in parallel. If those colors are different, they will not be in parallel. We write this form in this way. We say R equivalent is R1, and these 2 little lines are 2, and the 2 little lines are 3. The 2 little lines mean parallel. So that's the notation for parallel. And then when you write the equation, you have to take 1 over 1 of each of the elements. Okay. Questions on the mathematical way of finding those? Okay, then the trick is identifying, am I in series or parallel? So that's what we're going to try here. So looking at this, I'm going to highlight all the nodes. One other note is when I have these nodes A and B, assume they're connected somewhere else. So you assume another element connection. And you treat these as extraordinary nodes. Okay? So even though there's just floating there, this is going to be the exception of you know that you're actually connecting it to something more complicated, and therefore you're treating that node as an extraordinary node. Otherwise, it's going to be hard to understand the equivalence between the 2 locations. So treat as an extraordinary node. So then I'm going to highlight all of my nodes. And again, I'll go back. I forget to do this, but if you need, circle the elements first. And then draw along a wire till you hit an element. So here we see we have 3 different nodes. And because we have been told that A and B are extraordinary, you have 3 extraordinary nodes here. What do you notice about the pink?
Some higher standing too.
Okay, so any thoughts about what's happening there?
Really short.
Okay, so that is considered a short. This means it is connecting on both sides of a resistance, in particular the 2 ohms. And there's no voltage drop, so V equals 0. So knowing with Ohm's law, you can look at it that way. If you have no voltage, then your current's 0, and your resistance is going to be 0. So V equals IR, so both of those also have to equal 0. And so if you have a short, meaning you have a wire in parallel with the resistor, you're going to ignore that resistor. So ignore that resistance. And then is 1 ohm in parallel with 6? No. Why? Why is it not in parallel? 6 has pink on one side and green on the bottom, right? The 1 ohm has pink but blue. So the colors are different, so therefore they're not in parallel with each other. What about the 6 and the 6? Those will be in parallel. So I have 6 is in parallel with 6 because they're pink on one side and green together on the other side. So 6 ohms is in parallel with the 6 ohms. So those 2 are in parallel together. So when you become parallel, you can redraw the circuit to look like this. So the A to B, 1 ohm, and then 6 in parallel with 6 becomes 1 over 6 plus 1 over 6. So 1 over 2 over 6, which becomes 3 ohms. So with that, hopefully then you can see that as I highlight these, they are in series. And those are all connected by ordinary nodes now. And so I would say that we have 6 ohms in parallel with 6, which is 3 plus 1. So this answer would be 4 ohms. All right. Questions? Okay, so I will post the solutions for this equivalent resistance problem and then for the other one for extra practice for you guys. And then we'll go through more problems on Wednesday. And I'll see you guys there.